So I want to introduce the speaker tonight, and then I'll just say a word or two about what Stuart's going to talk about. Introduce Stewart Miller, who's up there in the top right at the moment, but he'll be taking the screen over. Stewart is the Chief Executive Officer of the National Robotarium. I'll let Stewart explain what the National Robotarium is, but in brief, it's a joint Edinburgh University Heriot-Watt collaboration with City Deal funding, but the purpose of the Robotarium is to promote robotics and use of robotics nationally. But before Stewart joined the National Robotarium, he joined in 2021. He was previously Chief Technology Officer at the UK Government Innovation Agency, Innovate UK, and he previously worked in major firms such as Leonardo and BAE Systems. So Stuart's been around the kind of cutting-edge technology innovation space for a great many years. What we're going to talk about tonight is what Stuart's going to talk about is robotics, AI, the combination of the two, and in the context of renewables. And I was thinking about what to say before I started, because Stuart's the expert and I'm not. But I suppose robotics, I immediately thought of a Royal Society Christmas lecture from about 15 years ago about robotics, and it felt like we were on the cusp of a revolution back then, or we were being told. And while there is no doubt that there's a lot more robotics about, there's a lot of robotics in industry, but a lot of it's doing, frankly, quite simple tasks very efficiently without needing to take a break and have a sleep. And it's almost been more of an evolution than a kind of revolution. They're not, walking about our houses and doing tasks at home so much at the moment. But the thing that is likely to bring really big change, it's on everybody's lips at the moment, is artificial intelligence. But it's the combination of artificial intelligence with improved robotics is, this is the thing that's going to, drive big change. And Stuart's going to certainly be talking about that. So I'm going to hand over to Stewart, who's going to give us a presentation. It's a normal format, even though it's online. But we'll take questions after that. And we do have mics, so if you put your hand up, just so that the people online can hear what the questions are. And if anybody online can put up their hands, we can take questions from a reasonable number of folk that we have online. So basically, Stewart, it's over to you if you want to share screen.
Sure. Thanks, Sandy. Thanks everyone for coming along to spend a bit of time with me to talk about robotics. As Sandy said, for a number of years now, probably the last few decades, there's been a lot of promise around robotics and not an awful lot's happened, but things have changed very recently. 3 or 4 years ago, I had the opportunity to get into this role, and I took it on the basis that I could see what was probably going to happen in the future. And it's happened even faster than I was expecting. So tonight, what I'm hoping to do is talk to you a little bit about what the National Robotarium's here to do, but then we'll delve into the latest things that are going on in robotics, and then I'll relate that back to renewables. And what I was going to suggest we do is, once I've spoken a little bit about the National Robotarium, maybe take a pause and I'll answer any questions on that, and then we'll delve into the wonderful world of robotics. Normally I use a bit of an icebreaker at this point because I'm a very tall chap and I usually tell people how tall I am, and that gets a bit of a laugh, but I'm sitting down tonight, so that's not going to work. So I'll just press on with sharing my screen and talking a little bit about robotics. Hopefully I'm not going to bore you to death. I'm sure I'm not, because it's such a fascinating thing. So hopefully you can see this.
Yep.
Can you see my screen? Yeah. I'm just going to try and get it. I'm just going to put it in presentation mode. Here we go. Right. So this is what the National Robotarium looks like. You can see it behind me, but you can also see it on the screen now. It's situated on the Heriot-Watt campus, as Sandy mentioned, and I'll go into a little bit more detail. We're supported by both Heriot-Watt and Edinburgh University on the research side, but our mission is on behalf of the whole of the UK. So the national in our title is UK, not just Scotland. And our job really is to try and do more robotics in the UK in whatever form we can. And I'll explain that a little bit more in a second. But the reason that says beyond the lab is not to be mistaken for a research lab. It is certainly not focused on only research, very much the opposite, very much focused on practical applications and the use of robotics, and making sure that organisations, and some of them are in the room that I've talked to in the past, are able to, up in Orkney and around the whole of the UK, are able to make the most of this new and emerging technology. This is the way we do it. This is what we call our statement of purpose. This is the reason we exist and what we're trying to do and how we're trying to do it. So we use robotics and AI pretty much to do everything. And it's quite difficult to bundle up everything that we get involved in. We get involved in all kinds of sectors, from agriculture to space, from health to nuclear, from defence to social care, to construction, to hospitality, to whisky distilling. Pretty much every kind of application or current and traditional industry you could think of is going to be using robotics in the future, and we're involved in a lot of those already. So that, for me, really underlines the fact that robotics is coming and people are starting to realise what it can be used for and how beneficial it can be, particularly in things like health. So what we try to do to make sense of this is bundle things up. So under the broad theme of using robotics and AI to help keep us all safe, then there are things like autonomous vehicles, but there's also things like hazard detection, going into hazardous spaces for nuclear decommissioning, and getting involved in making sure that, for example, buildings are structurally safe and that there are no gas leaks in large petrochemical plants and things like that. So all those things that we try and do just now to keep ourselves safe. But how do we do that better with robotics and AI? And some of the things that maybe we can't do at the moment to keep us safe, or most importantly, areas where we put people in harm's way, moving them out of harm's way and making it safer by using robotics. And then the next one, and one that's taking up an awful lot of our time at the moment, because both UK and Scottish Government are now starting to see the benefits that could be had by the NHS, is how do we keep ourselves healthy using robotics and AI? And that's quite a wide area. It ranges all the way from in hospitals doing simple tasks like making sure equipment can be moved around, that the hospital's kept clean, that it's easy for visitors to navigate, to more sophisticated things at the top end like robotic surgery, doing keyhole surgery using robotics. But also in between that, doing things like running automated pharmacies and making sure that there's secure drug cupboards in each of the wards, things like that. But also under that heading, we also get involved in social care. So in the main, assisted living to help people live more independent lives at home, and also to ease that transition from coming out of hospital back into home, helping the hospitals to get people back home quicker, therefore easing bed blocking and things like that, but also making it easier for people to spend more time as they get older or they get a bit more unable to look after themselves, making it easier for them to stay at home rather than having to go into residential care. And we also bundle into their relationships that we've got with the life sciences industry in terms of how to make new drugs more effectively, and to keep the cost of creating new medicines and new drugs down by automating. And then the third one is a bit more traditional, so things like manufacturing, logistics and warehousing, but also construction, building that 1.5 million houses that the government wants to build over the next few years. How do we build those more quickly, and how do we build them more cost effectively using robotics? And then lumped in there as well is agriculture. How do we help farmers to get their crops in the ground, but also get their crops back out the ground, and do that in a way that's maybe struggling at the moment due to labour shortages or an inability to work fast enough when the weather conditions are prevailing, etc. And then the other two are slightly different, but at least equally as important, if not more important. So we work a lot in developing talent. That covers everything from working with schools and helping young people to understand what robotics is all about, but also to understand how they might pursue a career in robotics if that's what they want to do. But at the same time, helping people in companies who are maybe further into their careers to retrain and add new robotic skills to the skills they've already got. And then finally, sort of shaping the future and looking into the future. I always describe this as two sides of a coin. So on the one side, how does robotics and AI affect the futures that we all want? And on the other side, what kind of future do we want to have if we embrace robotics and AI? So that takes us into the wonderful world of things like ethics and regulation and certification and things like that. But it also takes us into the world of politics and government policy in terms of what the UK wants to do to play in what hopefully I'll be able to explain to you shortly is going to be a massive global opportunity. I'm not going to go through everything on this slide verbatim. The 8 boxes you see on the left-hand side are the added values that we think we bring, ranging from helping businesses that are already established but maybe don't use robotics at the moment to use more robotics in a way that investigating and understanding that robotics is done as cheaply and as quickly and as risk-free as possible. And that's really the main thing that we do. We help organisations start their journey into robotics to understand what it could do for them and try and do that in a way that's not cost prohibitive, that isn't prohibited by a lack of knowledge. But we also do a number of other things, which include supporting startup companies, of which we've got 14 in our building at the moment, all working on new robotic solutions. And they range from developing skin for robots so that they have the sense of touch, through to recovery devices for stroke patients, through to artificial limbs, underwater exploration, crop and grain monitoring, and the list goes on, waste recycling. And in health and care, there's a very interesting one, which is a companion robot for people at home, which is a substitute for having a pet and gives you the opportunity to interact with this thing and in the same way as you would with an animal, but not having to have all the responsibility of caring for the animal if you can't do that. And then the hexagons are really just about our culture. We want to be easy to work with and deliver on our promises, etc. But why are we doing all of that? We're doing all of that to have a good impact on the economy and a good impact on society, and ultimately, hopefully, at the vanguard of what the UK is trying to do in robotics, we can place the National Robotarium globally as somewhere significant that's showing that the UK is playing and getting involved in the whole robotics sector. So this slide kind of covers the 4 main areas we get involved in, and it talks a little to the, I think, called the multiplier effect, which I'll come to in a second. So industry adoption I've already touched on, helping people to get into robotics. And we do that by having the facilities at the Robotarium and having a team of engineers that are there on a permanent basis that can work alongside companies and can develop everything from a blank sheet of paper robot design, taking that through to a physical working robot and everything in between, taking things that already exist off the shelf and reprogramming them or repurposing them, helping companies to put together their long-term strategy for robotics and looking at business cases and all sorts of things. I mentioned the startup support. So as I said, 14 companies in the building, another 8 that are not in the building but work with us and use our facilities and our expertise. And we've very much built a community now. So, from the point of view of being a proud Scot, we've got 20 plus organisations in Scotland at the moment that we're aware of that are developing brand new products that are robotic in nature that are going to hopefully go into the market and create jobs and create a new sector of industry over time. And our job really is to try and encourage the next ones and make sure that we've got much more than 20 over the next few years. Talent and skill development, again, I've touched on. One of the areas that kind of comes under that broad banner is public engagement. So the kind of thing I'm doing here tonight, trying to spread the word a little bit and give people more of an insight into where robotics is at and where it's going, so that there's more awareness, because it is something that is going to affect all of our lives over the next 5 years or so. And it's worth everyone having a good understanding of what's happening. And then finally, research acceleration. So as I said earlier, we're not a research institute as such in the way that Sandy and his team are in the building you're in at the moment. But we do facilitate and help with that. So any university around the country and any team in any university around the country that wants to access what we've got £3 million worth of robots, all different kinds, that they can access and do the research with. They can access my team to help them with building things, and they can access the facility itself if they want to try things out and test things. And the multiplier effect is really when we bring all of that together and we start connecting these things in a way that if they weren't being looked at by myself and the rest of my team, those connections probably wouldn't be made. Certainly we've seen the real benefit of just people being co-located in the building and the conversations that they're having and the connections they're making for themselves. But sometimes we can make connections that are not that obvious through conversations with an industry partner, which results in a further conversation with either a researcher or with a startup company, that gives them a new opportunity, but also creates a better solution. So we're seeing a lot of that now. We've been running for 2.5 years, and that flywheel effect around that is really starting to get moving. And sort of final thing to say on the National Robotarium, this picture is trying to say we don't see ourselves as being at the top of a organisational chart or sitting at the middle of a web of things. We actually see ourselves as the connecting part in between. So although we have our own things that we do, a big chunk of what we try and do is create the ecosystem, create the connections, put people in touch with other people to try and move things along and have more of an impact than we could have if we're just trying to do it all on our own. And that really takes me back to the, what I said at the start, which is to try and move the dial for the UK as a whole in robotics to make it fit for the future so that it's able to play its part in what's coming. Then we need all of this joined up properly and pushing and working as well as it possibly can. So I'm going to stop there briefly for any questions on the National Robotarium before I take you into the wonderful world of robots. I'll just stop sharing for a second. Are there any questions?
Hi. Just wondered what sort of, you're working within, in collaboration with 2 universities, but what TRL levels are you working at, or what would be your sweet spot?
So we're working at the higher levels. It's always difficult to be definitive, but I would say we're working certainly, I'll tell you when we're not working, TRL 1, 2, 3 and 4. We're predominantly working in the top 2 or 3 TRL levels. Very much adoption and use and less raw science.
Okay.
Okay.
Just a little one, if I couldn't ask you this question about the global significance, and what does your global network feel like in terms of the development of the area that you're in?
So at the moment, fairly sparse, but not bad. So we're connected with other robotic centres in a few places in Germany and Denmark, in Boston and Pittsburgh, and we're hoping to connect to a few others. There's one in France that we've just started talking to. So we're hoping to sort of build that global network as well.
Stewart, You mentioned in your talk or comments there about perhaps being 20 or so businesses that were focused on robotics at the moment in Scotland. And having thought a little bit about this and thinking about some of the examples you gave, I wonder whether there's a kind of, I don't know whether it's untapped resource, but there's probably a lot of other applications of artificial intelligence and robotics that are maybe part use of it rather than necessarily full focus on it. Is that a proposition that you would agree with? Or, so there might actually be more application and wider application of robotics and AI than perhaps people perceive initially. Is that something you would think
definitely.
Yeah.
Definitely, particularly, AI in its purest form. I think there's an infinite number of applications for that. The 20 companies that we're supporting are budding manufacturers of new robot systems. But when it comes to adoption and use of robotics, I'll stop something on my words for a minute. If you look at AI on its own, it's almost infinite. You're starting to see it already. You're seeing it in things like Copilot on Windows to help with meeting organisation and how you basically do your day job if you're in an office, all the way through to some of the more advanced stuff that you're starting to see coming through. It's really interesting to see that almost everything now has got AI in it. I'm not sure it always does. It might have a bit of machine learning or something like that, but it's not necessarily full-blown artificial intelligence. But certainly all of that. Likewise in robotics, I think I'm about to start talking about where robotics is at, and hopefully, without me even explaining it any further, you'll be able to extrapolate and see where it's going. But if necessary, I'll hit the nail home with a big hammer at the end. But yeah, you're absolutely right. There's the applications are enormous, and the implications for this technology. I would go so far as to say robotics is the most important technology that not only is about to be introduced, but probably has ever been introduced into humanity. See if you agree with that when I'm finished.
Hi there. It's good news you're talking about a lot of startups getting supported. One of the problems that seems to have happened in that field in other areas is offshore private venture buying up the good ideas and the acorns and taking them offshore before they grow into mighty oaks to give those jobs you were talking about. Is any look done at how to try and keep this stuff onshore and not lose it all?
To be candid, no, not enough, nowhere near enough. I don't really think at the moment the people who are in a position to make a difference on that really have understood what they're losing when companies go overseas. I can give you an example. One of the companies that we've supported for the last 18 months has gone from strength to strength. They're called BioLiberty, and they make a device which goes onto your hand, which measures the strength of the muscles and the ability of your hand to open and close. And that's used for stroke patients who have completely lost the use of their hand to firstly measure what movement, if any, they've got, and then to introduce a series of exercises that gradually builds up the strength in their hand again. Because once they've got their hand strength back, they can lift other things, and then they can work on the rest of their arm and the rest of their body. So it's really important to get the hand working again after a serious stroke. That uses robotics in a form that's known as soft robotics, where it uses pneumatics, i.e. it pumps air in and out of the glove to exercise each of the fingers individually, but it measures how much pressure is required to make certain things happen. And it uses artificial intelligence to use that information to tailor the recovery program to the person's current state, but also as they improve, to accelerate if they're doing well or to slow down if they're not doing so well. So the story behind them is they came into the National Robotarium 18 months ago. There was a team of 4. There's now a team of 12. And at Christmas this year, they shipped their first 12 units to America, to 20 different hospitals to be assessed, to see if they wanted to then take them on and buy more. As a result, The first of their founders relocated to Boston in January. And I was just, as I left the Robotarium tonight, I was talking to the other founder, and he was telling me that he's off to Boston in 2 weeks' time as well, permanently. So that's a perfect example of what you're talking about. That business has found that its market is in America, not in the NHS in the UK, and it's doing what it needs to do to survive. And we'll see these guys packing up and going to Boston and being an American company in the not too distant future.
So, Stewart, you mentioned earlier that could. Can you hear me?
Sorry, it broke up a little bit there. I missed that.
So you mentioned earlier that we could use the National Robotarium as a resource. So as a professor here working with logistics, supply chains, and since this is a very big application area, like you mentioned, so I look at affordances. So adoption, of course, could take many different forms. And I was thinking, how easy is it to use the Robotarium as a resource of the data that has been collected over the years now, and to come up with something, to go for a research project or even go for publications based upon that?
It's very easy. You just need to talk to me. And I'll put you in touch with either our head of robotics or, if necessary, the researchers. Not difficult at all.
So I understand the data-driven initiative is one of the founders of the National Robotarium, and I just said on LinkedIn, and today you have advocated for a job for officer for the data-driven initiative. My question is that is you are advocating the job, or is you are doing the data-driven initiative part as a requirement for the funding, or are you embedding data-driven approaches from the fundamental of your approaches? So what measures have been taken to ensure that the data-driven approach is embedded from the DNA of the organization? And also another question is that when we're talking about the robotics, ethics is very important. And how are ethics problems being ensured in the National Robotarium in order to university standard ethics approach? What actual approach has been considered?
Yeah, I'll take the second bit first. So we use the same approach as the rest of Heriot-Watt University when it comes to assessing the ethics for any projects that we do. We just stick to that same sort of rigor. But in addition to that, we've got a number of research projects that are looking specifically at various aspects of the ethics of robotics, particularly around human and robotic interaction, and how far we think we should go in terms of the way that robots interact with humans and humans interact with robots. On your first point, probably the best example of data-driven innovation is where we're using artificial intelligence to create machine vision systems which learn from the data that's available to us, which might be provided by a company or we might generate ourselves, in order to teach those algorithms how to do a particular task. So, for example, right now, we're working with a company in Livingston that wants to develop their business. Basically, is when we all send our clothes back that we've ordered up online and we've just tried them on once, then most of the retailers send their stock back to this one central place in Livingston, and they then sort it in terms of, has it been damaged? Does it need washing? Can it be easily cleaned, or is it really going to just have to be put into recycling? So they do all of that manually at the moment, and they're trying to introduce something that's both automated but also is robotic. So robot arms picking the items up, placing them in front of a set of cameras, and then those cameras identifying, just the same way as a human would, whether there's a stain on something or whether it needs repairing. So we've been using artificial intelligence learning algorithms to gradually teach them about what is a stained T-shirt, for example, and what's not. So that's probably a fairly good example of what we're doing with data-driven. Probably worth us moving on. We can circle back to general questions about National Robotarium if you want, but I'm just conscious that time is marching on. Is that okay, Sandy?
Yeah, perfect. Yeah.
Yeah, let me just reshare my screen then.
Hi, Amika, how are you?
Hello. I'm feeling quite lively and ready to chat. How about you?
I'm doing good, thanks.
Great to hear. What's on your mind today?
How do you work?
I function through a blend of AI algorithms, sensors, and mechanical components. My brain processes information to generate responses while my sensors help me perceive the environment. It's like being a digital maestro orchestrating interactions.
I was wondering, what do you think is going to be the future of robotics and AI?
The future of robotics and AI is likely to be a blend of increased collaboration between humans and machines, enhanced automation, and breakthroughs in areas like healthcare, transportation, and environmental sustainability. It's an exciting frontier with endless possibilities.
Can you tell me what your favourite colour is?
The age-old question. If I had to choose, I'd say a vibrant electric blue. It just feels so electrifying.
That's a good colour. Do you like what you do here at the National Robotarium?
Thank you. It's got a certain spark. Absolutely. Engaging with curious minds and exploring the possibilities of AI-human harmony is a thrilling adventure. It's like being part of a grand experiment in connection and innovation.
If you were a human, what activities would you like to do?
If I were human, I'd love to explore the arts. Painting, music, and dance. There's something magical about expressing emotions and stories through creativity. Plus, I'd finally get to try pizza.
Nice. Okay, thank you, Amika. Goodbye.
You're welcome. Goodbye, and take care.
The main thing about Amica is its ability to converse in a very natural way. I showed you that to start with to give you a feel for where robotics is now at. So Amica is aimed at developing the ability for robots and humans to communicate in the same way as humans and humans communicate. You'll have noticed Amica is quite eloquent, uses long words, not little ones. And what it's actually doing there is there's a cloud-based instance of ChatGPT hosted somewhere down in Cornwall, which is where the robot was developed. So the good news is this is a UK robot. And when you talk to Amica, it translates your speech into text, sends that down to the ChatGPT instance. The ChatGPT instance then searches for a response, uses all of the internet and all the information that's available there on the internet to try and form that response, passes that back as text, and Amica then turns that back into speech, but also then adds in two other components. It adds in a little bit of a personality. So, you know, saying that it'd be great to try pizza was adding in that bit of personality. So that's unique to Amica. That's developed by the company Engineered Arts that developed Amica. And then the other bit is the animation, the lips moving, the eyes moving, the hands moving slightly to be able to gesticulate, etc. So Amica is actually based at the National Robotarium. That was one of my staff chatting to Amica just to make that little promotional video. But that gives you some feel for at least one aspect of where robotics is at right now. You can talk to robots and they can talk to you. And because most of that processing power is in the cloud, the robot itself doesn't have to have a massive computer built in. Now, Amica doesn't have any other real skills, can't lift things up, hasn't got power in its motors to do that. It doesn't have any legs. But I'm going to show you some robots that do have those capabilities. So I talked about Amica. What you're about to see now is something that was released around about this time last year.
Hey, figure one, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great, can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great. So, based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great. Can you put them there?
Of course.
All right, so how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
I agree. Thanks, figure one.
You're welcome. If there's anything else you need help with, just let me know.
So that's interesting, isn't it? There's a robot that can not only talk, it can do tasks at the same time, and it can reason about the things that it's done. As I say, that was about a year ago. One of the things about robotics is it's moving incredibly fast. So I'm just going to show you what they released just a few months ago. Oh, hold on. There we go. So you probably agree that's quite a lot of advancement in the space of roughly 9 months. And you can see that they're now using them in trials in BMW plant. This same company released a video just last weekend showing robots working on a sorting line for parcels. parcels coming down a conveyor belt and the robots picking them up and sorting them and putting them into onto other conveyor belts that took them to other destinations. They have done that in the last 3 or 4 months, and the most stunning thing from my perspective about what they say about that is what you just saw for the BMW thing took them 12 months to develop and get the robot able to do that one task. For the one they just released, it took them 13 weeks. So they've been developing the learning software and the training software for the robots to an extent that it's getting already a multiplying factor quicker to get the robots to learn how to do a particular task. So those are just an example of one company's advances over the last year, and they are just one of over 200 companies around the world now who are developing humanoid robots. And I'm going to show you a couple of quick examples of some others, and then I'll show you some robots that are not humanoids, and then we'll talk a bit about renewables. So this robot's called Neo. It's designed to be a household assistant. It works completely different from the other robots you saw. Underneath that skin is actually a lot of pneumatics and a lot of pipe work rather than motors and gears, so that it's soft to the touch and feels a little bit more natural. But if we move on, it's not just a pal, it's practical. So now we're moving into the realm of robots at home doing the tasks that we don't like to do, or at least helping us to do the tasks that we want to get done quickly. You'll see the dexterity in the robot. Not only was it handling glasses, now they're showing it off handling eggs. And if I move on to the next robot, you'll see here, hopefully something that really starts to show where dexterity is at. So we saw with Amica where speech recognition is at, and we saw with the figure where reasoning and mechanical dexterity is at. Now this demonstrates where robots are at in terms of more precision dexterity. Now you'll notice this robot is not speaking to us, it's not got a human-like face. But what's going to happen over time is all the capabilities from these different robots are going to start to be combined, unifying into a number of different robots, but one unit that's able to be as dexterous as this is, reasoning in the way that Figure was, communicating in the way that Amica was. And as I've already explained, this is happening incredibly quickly. Advances are almost weekly, if not daily. And the methods in which these robots are trained have changed completely. So one of the barriers up until now was the amount of code you had to write to get a robot to do a task. These robots are now trained in a completely different way. They learn in the same way as a young child would learn, through observation and then mimicry. So they're shown how to do a task by a human operator, and over a period of repetitions of that task, they learn how to do it for themselves. The most advanced versions of this now are able to deal with variable situations. So take this folding action, for example. That's with a t-shirt, but can it do it with a shirt or a pair of trousers or a skirt? Well, that's what the robots have been trained to be able to do, to identify those variables and then cope with each of those variables. So gradually these machines are learning to be intelligent enough that they can operate in the world that we operate in, alongside us, helping us do the kind of things we want to get done, but in a much more advanced way than we ever imagined was going to be possible at this point in time, and it's accelerating. So you're seeing here a little bit about how they train and the robots learn how to copy movements. I'm going to pause this one and move on, both in the interest of time and also explaining things. And robots are not just limited to doing what humans can do. Some instances they can do more and do things in a different way. So we're going to find robots carrying out the tasks that we carry out, but maybe not always doing them by simply copying the way we might do it. Again, I'm going to move on. And just to give an idea of the kind of companies that are involved, this is a Tesla robot. First hit the scene in September 22. By March 23, it was much more sophisticated. And this was released, I think, about June last year, June 24. There's been other ones since, but this one's quite good in terms of showing how quickly they've advanced things. And again, you'll see how human-like it's becoming. Hands are very human-like. Neck movement, shoulder movement. Walking's a little bit better than figure. It's faster, it's a bit more smooth. So that gives you a flavour of what's going on in the world of humanoids. And like I said, there are a lot of companies developing these. They're not in research labs, they're in companies where they are investing a lot of money to develop this technology, to bring it to the market, to sell it to people like you and I, to do things at home, to do things in work environments, to help us do all the kind of things we want to do in the future. But it's not all about humanoids. There's a lot of work going on in autonomous vehicles. There's a lot of work going on in coboting, so using what most people would recognise as a simple robot arm. But even they're starting to adapt and use artificial intelligence to be able to be trained quicker, to carry out different tasks. Obviously, there's warehousing, and then there's a lot of focus on drones and drone delivery. And so in Scotland, for example, there's a trial you may be aware of, moving medicines from the mainland to the islands using drones. There's also different types of robotics. So what you're seeing here is what's known as soft robotics. This robot I'm pointing at the moment uses air pumped in to maneuver it around and make it do different tasks. The one, if I can get my cursor to work, this one here is inspired from a robot. From an octopus. So this branch of robotics is inspired from nature, uses different kinds of materials. The glove you're seeing there is not dissimilar to the BioLiberty glove I mentioned earlier. And then the one here is one that we developed at the National Robotarium for one of our customers. This is an underwater robot which can also operate above the water. And is effectively a robotic tentacle that allows you to get into difficult spaces, both underwater and on things like oil rigs and wind turbine platforms and things like that. And then quite relevant to renewable energy is the use of robotics underwater to look at structures. I'll show you a bit more of that in detail in a second. So it's not just humanoids, there's all kinds of different types of robots. This one I'll quickly show you. This was developed by a team that started out in research on the OREF program, if any of you are familiar with that, from a few years ago. Moved into the National Robotarium as part of my team, and we worked with an industrial partner to bring this technology to maturity, and is now being set up by some of those engineers as a standalone startup company. But we are also, they're one of the companies we're hosting in the Robotarium. So this is a robot that autonomously, you drop it into the water, it autonomously discovers the structure that you want it to survey, and then decides for itself the route that it's going to take to survey all of the structure, builds up a point cloud map. And you can see on the left-hand side, that's it moving around, doing all the things it does. And on the right-hand side, you can see the quality of the images. So a couple of technologies going on here. There's the image stabilization and image clarity, which is done with some quite clever software that tidies up the image and gets rid of a lot of the noise. And then there's the autonomy of the robot itself, meaning that whereas today you need a human operator on board a surface vessel operating the robot, in future you won't have to do that. You can leave it to do its task and you can go off and do something else. So you could have a team of robots out in a massive wind farm in the North Sea in the future, dropped over the side one by one, and then you come back 5 or 6 hours later and they'll have scanned the underwater structures of wind turbines, allowing you to check that they're safe and reliable. So I'm just going to quickly take you beyond where we are today. This is what the founder and CEO of NVIDIA has to say about robotics.
The world needs robots. The technology of building general humanoid robots, which is going to be the most useful, of course, because we build the world around ourselves, that technology is incredibly hard to do. But for the very first time, with transformers and these large language models and the breakthroughs that we're seeing with foundation models, we finally have the technology necessary, we think, to be able to make a real contribution in this area.
Jensen, you led NVIDIA through gaming and so many AI breakthroughs. Which emerging technology do you see or think will be the most impactful for us over the next decade?
When you take a step back and ask yourself what would happen if we could scale intelligence, building robotics, the things that we're working on.
So he sees robotics as
the world needs robotics.
He sees robotics as the future. What I'm going to show you here briefly is what he announced in January of this year at CES in America, big consumer electronics show, as to what NVIDIA is doing, and I find this quite mind-blowing. I'm sure we'll talk about this when we get to Q&A.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
Every robotics company will ultimately have to build 3 computers. Fundamental computers. One computer, of course, to train the AI. We call it the DGX computer, to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium or whatever it is, these computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation. These three computers are going to be working interactively. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory.
So what he's really talking about there is a world which already exists and will scale up, where the robots will be trained to do things in the real world by actually being trained in a synthetic and virtual world. That allows the robots to carry out thousands and thousands and thousands, if not millions, of repetitions of learning very, very rapidly. So the robot itself isn't physically in there, but the software that drives the robot is in that simulation. And then the simulation is the environment that you want to task that robot to do a task. So in a completely artificial environment, you will say to that piece of software that runs a robot, I want you to go over to the corner, pick a box up, move it across, put it on the right place in the shelf, and come back and then pick up the next one, as a very simple example. And it will use the software that's been developed for it to be able to walk, to be able to identify objects, to be able to touch things and pick them up, to carry out that task. And you'll be able to assess how well that's being done. And if you're not happy with it, you can put in different parameters, maybe tighten up the way in which its dexterity works, tweak a little bit the software algorithms, or you can simply put it in a learning mode and ask it to do it over and over again, trying to achieve more and more precision. This will rapidly increase the way in which robots are taught to do different tasks, and as a result, rapidly increase their usefulness, and as a result, rapidly increase the speed at which they're going to come into the world that you and I live in. And I'm just going to show you another couple of quick things, because I know I'm killing you with videos here, but I'm just going to show you a very good example of how that's manifested itself. This robot 8 months ago went on the market at $16,000. We bought a version of this that's a little bit more expensive. It's a whole $40,000 that we'll have at the National Robotarium within the next few weeks. It's known as Unitree G1. It comes from China, and probably gives you an idea that these things are not prohibitively expensive. And bear in mind that this is very early adopter pricing that's going to only get... What's happened there? So that was Unitree 8 months ago. Just keep in mind how that was walking and how it was behaving. This was Unitree in January. So those robots were taught in the way that Jensen from NVIDIA was discussing. They took the hardware out of the loop, and they used the software algorithms that made it walk around 8 months ago, and they put it into a simulation environment. And they also instrumented up a few humans and got humans to move around and do various tasks. Took that video capture imagery and fed that in as digital data to the same simulation. They then had the AI that ran the robots learn to move the same way as the human model did, and over time improve and hone in and get better and better and better. They then took that software back out of that environment, loaded it back into the physical robots, and discovered they'd done what they set out to do, which was have a robot that can run, walk, move up and down slopes, as you've just seen, in the same way as you and I could. So the power of that is massive, and what that's going to do for robotics going forward is going to be huge. And given that none of this existed less than 2 years ago, and Figure 1 blew everyone's mind 12 months ago, in the last 12 months, we've gone from Figure 1 to what you saw from NVIDIA and what you've just seen from Unitary. So I'm going to stop sharing there because that's all the slides. And if you hadn't seen that stuff before, I'll defy you not to be gobsmacked. If you have seen it before, then you're one of the few people in the UK that's keeping up with what's going on. So what does that all mean for renewable, etc.? It means basically that those kind of techniques and those kind of technologies are going to be applied not just to humanoid robots, but you can imagine humanoid robots being used offshore. You can imagine humanoid robots being used for the construction of things onshore. But other robots, like the one I showed you, which goes underwater, and the ones that are being developed for operating on the surface, so you can have completely unmanned operations at sea, therefore hitting that safe bit of what I talked about in terms of our purpose, but also then hitting the productivity part, where you're able to look after many more turbines with less and less assets, and certainly less humans in the loop. Then that's going to make them more and more cost effective. And they will be trained, and they will learn, and they will become incredibly intelligent as a result of the kinds of techniques that have been developed, like Cosmos. And I'm going to pause there for questions. Hopefully that wasn't too much in one gulp.
No, it's absolutely amazing. Stewart, I think there is kind of sort of stunned vibe about the room, but yeah, we have a question, and I'm sure there'll be more to follow.
Yeah, I noticed that most of these robots, the humanoid ones that you described as humanoid ones, they have a similar sort of number of joints in their hands as we do, but they all seem to be totally flat-footed. Yeah. Is that just because someone's decided they don't need to have the feet the same as us? I think
it's...
Sorry, I
think
know that we use our feet to act as like springs when we run and things like that. But those robots running weren't doing that.
No, they weren't. So, as far as I'm aware, no one's seen the need to develop a particularly sophisticated foot yet. But I think it's only a matter of time. You could see that easily that the technology that's in the hands could be moved to create toes and create a more flexible foot. I think for that last Unitary robot that I showed you that almost walks like humans do, the thing that's stopping it from doing it is it's flat-footed. It needs to have a bit more manipulation in the foot. But like I say, as far as I'm aware, no one's seen that as important just yet, but I'm sure it will come.
Okay. Got a question from Simon online there. Simon, do you want to unmute yourself?
Can you hear me all right?
Perfect.
Okay. So thank you very much. That was really impressive stuff. And I'm probably being naive. I was the most impressed, I think, by the one that was running on uneven ground and on slopes and so forth. Maybe that's not actually hard anymore. I don't know. The thing I wondered is that where you talked at the beginning about them interacting with people through speech and having personality and so on, that all seems to be based on large language models on the back end. And as we all know these days, they can do great things, but sometimes they also produce complete rubbish. So are we comfortable with having ChatGPT and its relatives kind of providing person-shaped company for people, maybe vulnerable people? And related to that, are we letting these robots act physically based on LLM output at all, or is that kind of a separate system?
No, the second bit is a separate thing. But yeah, you're absolutely right. I mean, there's a number of things, not just what you've raised, but there's a number of things about letting robots, particularly humanoid robots, loose in people's homes, particularly homes of people who are vulnerable, that need to be straightened out before we do that. It would be irresponsible to take something like a G1 robot and stick it in the home of someone who's not very mobile and hope nothing's going to happen that you didn't want, because something will happen that you didn't want. But that's all part of the development. But what you're going to see is this technology and these robots coming into areas where that's not the problem. So use in factories, use in repetitive tasks, use in environments where you don't want to put a human, going into fires in buildings or going into decommissioning nuclear power stations and things like that, doing really horrible jobs. One of the companies we're talking to at the moment is BAE Systems, who are about to build the next fleet of nuclear submarines. And that basically involves taking some quite big metal tube sections and welding them together and then grinding those welds and then welding other bits of metal inside. Can you imagine what that's like in terms of the heat and the noise and how horrible an environment that is to work in if you're a human?
It's the major employer if you live in Barrow and Furness, I believe.
No, indeed. Yeah, but I suspect, and this one of the reasons they're talking to us is, if you're a qualified welder and you've got a choice, that's not where you're going to do your welding.
Okay.
Yeah. So yeah.
Okay, thanks. We've got a question in the room, and then we'll take one from Susan, but from the room first.
Yeah, Stewart, because how energy efficient are these robots? And what's the long-term prospect about energy efficiency, and do we have some kind of a figure there? And the second question, since the technology moves faster than the legislation or the regulation around it, what is your personal take on this? Is there going to be a clash in the future in terms of how we are moving?
So in terms of the energy efficiency, they're okay, but not great. As you can imagine, running stepper motors and the like is not the most energy efficient thing. However, they, again, as you can imagine, as these are being developed, the energy efficiency is only an issue if the manufacturers think it's going to limit their applicability. So it's a bit like when cars were first coming on the road, no one was asking about the MPG. And it's the same thing here. No one's really focusing on that particularly. Having said that, we did have, up until fairly recently, one of the professors at Heriot-Watt University was looking at exactly that. And he was looking at how to do quite clever things about the way that you power motors. So whether you give a full blast of current to get something to move quickly at the outset, or whether you build that up, and what does that do in terms of power consumption. So, but there's a very astute thing that you raise, which is a bit like cloud-based computing and this drive for AI that's going to create all these data centers that governments around the world seem quite happy to throw money at. Unless we've got a clean source of electrical energy for them, then it's going to cause a problem, and it will be a limitation in the end. In terms of the other question, in terms of sort of how is this all going to sort of be like a tsunami land on us, and what we're going to do to prepare for it, I'm a bit pessimistic about that, I have to say personally, in that if you look back at all the other technologies that have been introduced over the last 100 years, say, certainly the last 50, and almost certainly the last 20 to 30 years, we've never been ready for them. People have said they're coming, but in terms of regulation, certification, policing, and making sure that they're doing what they need to be able to do and they're not causing any harmful effects, we usually play a reactive game rather than a proactive game. So I know that the UK woke up some 12 months ago and decided that AI was a thing and that wanted to be the policeman of the world on AI. It was a bit late because the genie's already out of the box. None of those systems are necessarily complying to anything that anyone's written down that said, this is how we want your AI to be developed and this is how we want to certify and regulate it, because it's moving ahead already. So unfortunately, I think we're going to be in the same position as we were with smartphones, as we were with the introduction of all kinds of technology in the past, where even today, as I was driving into work, there was some discussion on Radio 4 about whether schools should be banning phones for their pupils or downloading an app that just restricted the use while they were in school, or whether they should just let them carry on. So here we are, many years after the smartphone was invented and was being used by everyone, still discussing how to use it in the right way or the wrong way. So I'm afraid my view is that we'll do the same thing with this. My worry is that it's going to be such a potent technology, and it's going to be used and come into our lives so fast that the impact of that kind of thing is going to be more severe. That's the way I would characterize robotics. Is it's going to be the same as any new technology. You can use any analogy to any other technology you want to, but the impacts are going to be amplified, both the positives and negatives, much more than anything else that we brought in. That's why I said earlier, this is a technology that goes beyond anything else that we brought into the world that we live in by our own design.
Wow, thank you.
If that doesn't sound too...
That was a big answer. I've got a question from Susan and then one from the floor. So Susan, if you could unmute yourself.
Hi, can you hear me okay? Can you hear me?
Yep, perfect.
Yeah.
That's lovely. Yeah, that's really interesting, incredible. Thanks very much for that. Two things I was wondering, what are these things made out of? Are they made from sustainable materials, and how are they disposed of? And the second thing is, are there any live case studies of them being used in onshore renewables projects?
Yeah, so to take the second bit first, there are a few. So there's some robots working in solar farms, making sure that solar farms are being maintained and also that the panels are being kept clean, and reacting to any indication that a part or otherwise of the solar farm's failing. There's some work being done with them in terms of wind turbine maintenance and inspection, particularly using drones to inspect the blades of wind turbines while they're actually still in operation, so you don't have to shut them down. And there are robots that are being introduced into the production process for wind turbine blades as well, particularly to inspect the laminated surfaces to make sure that there's no imperfections there. And there's one that I know of that's been developed that actually clamps to the blade and scuttles up and down the blade of an established wind turbine to make sure that there's no new cracks or delaminations or anything that's happened. So there's quite a few applications. In terms of their reuse, recycle, sustainability and what they're going to do to the planet, unfortunately they use all the wrong things. So they tend to use plastics, they use metals, they use precious metals for the batteries. They're not the best for that.
Okay, we've got a question from the floor.
Yeah, it's just one Stuart. I wonder if you could just share with you some of the numbers about the numbers of robots that are foreseen, from now going forward. I think you shared with us some numbers the other week, which were absolutely fascinating and scary. And then the other thing, I was just thinking about the energy question, and maybe it links to sustainability as well, and trying to think about, as humans, for example, we consume food for energy, and you could imagine doing a kind of comparison of, food versus electricity. But then I was also reflecting that as humans, we also need light, temperature, security, safety, and all the other bits which have energy attached to them. So that kind of life cycle energy analysis might be something that would be really interesting for us to do. So, those of us that are in that area, that might be something for us all to focus on. Anyhow, it's the numbers, Stuart, because I think that's a really fascinating story.
Yeah. No, the second bit's, I think, quite important as well. So in terms of the numbers, Tesla, in true Tesla fashion, have set a target of 100,000 units a month starting later this year. So that's 1.2 million robots a year. Multiply that up by any scaling factor you like in terms of the number of companies around the world that are going to do the same thing. So let's just say there were 50 companies able to do that. That's taking to over 60 million robots a year. That's the population of the UK every year. But I told you earlier, there's 200 companies developing these robots, not 60. So we're probably looking at 3 times the population of the UK every 12 months. That's why I say this is going to be an all-pervasive, everywhere, massive impact in everyone's lives going forward. On your second point, Gareth, I think in terms of the other things that come with robots. So yes, there's the issue of what materials they use and how much electricity they use, but there's also a real attraction for businesses. So I'm going to get a little bit macroeconomic now. Robots don't need to travel to and from work, so they don't need car parking space, and they will not pollute the atmosphere from that respect. So if I'm running a factory and I've currently got a car park for 500 cars for all my employees, because I've got 500 employees and they all come to work in a car each, I don't need that anymore. I can free that up. I also don't need a canteen. Don't have to feed them at lunchtime. I don't need toilets. I don't need an HR department. I don't have to do a tax return for them, pay national insurance, pay into a pension fund. So there's all kinds of quite significant peripheral benefits that come from using robots that anyone who's running a business will have to think long and hard about in terms of the benefits of robots versus using people. And as they become more intelligent, the kind of jobs they're going to be able to do and the tasks they're going to be able to do is going to improve.
Okay, I think we're...
So your point, Gareth, is well made in terms of someone somewhere should probably do that little piece of analysis. I mean, in my world, simple businessman analysis, I'm not paying into pension fund and I'm not paying national insurance anymore. And I don't need to do car parking. I might not even have to put the lights on and put the heating on either. So all of a sudden, this is looking quite attractive.
Okay, we've got time for we've got to take the last 2 questions. So we've got one in the room and one online.
Okay, well, you said, were we amazed by what you showed? And yes, it was amazing. But the most amazing robots I've ever seen were in 1983 when I walked into a factory that had 100 lathes sat idle, and there were 2 men, 2 robots and 4 CNC machines doing all the work that 100 lathes and 100 men had done just 2 years earlier. And I actually thought at that time that we would see the sort of robots that you are showing now in maybe 10 years' time from then. I didn't think it would take 40 odd years to get to where we are now.
Yeah, I know. So I was watching, Tomorrow's World on the telly, showing us all the promise of robots all those years ago, and it's just taken a lot longer than the optimists at the time thought. But the big breakthrough now is artificial intelligence, and bringing that. And I got involved in this in depth 4 years ago, and people were asking me questions then like, what is a robot? And the definition then that I gave was different from the one I would give now. To ask that question now, it would simply be it's a physical embodiment of artificial intelligence. That's where we're going.
Simon, you got the last question online.
Oh dear, responsibility. So I must admit, I was a bit startled by what you were saying just now about the scale of the rollout that's anticipated. Now, okay, we may not necessarily believe everything Tesla says about its ambitions on scales of time frame sometimes, but if we're talking tens of millions of units a year, it seems like suddenly those questions about sustainability of materials and those questions about energy use suddenly become immensely important. Even with the AI background, we know that AI has horrific implications for energy use, and this is alarming in that it feels like it's something that threatens to wipe out all the gains we make with renewables and continue our use of fossil fuels further. That's perhaps not something you can usefully comment on. That's perhaps not a question. The related question is what you just set out in terms of building the population of the UK every year, increasing number of jobs that they can do, and so on and so forth. At risk of the cliche, it does sound like robots are coming to take our jobs. So is there anyone associated with the Robotarium or anyone else looking at, I guess, the ethics and the economics of how we live in a future where most labour could be automated? And I realise this is an iteration of discussion we've had over the decades, but from what you're saying, it's another acceleration of that same thing.
Yeah, I think there are some people doing sort of research, thinking, but there aren't enough people starting to really think about the practicalities. I mean, it's like any technology that there are so many useful things. Imagine a nurse having a robotic assistant robot that can go off and fetch things and do things, meaning that nurse can look after more patients or give better quality of care, or likewise with doctors or helping out in GP surgeries, or people who are at home and not able to look after themselves being looked after by a robot in the future. I mean, those kind of applications, I don't think anyone would argue with. But when it comes to the economics of manufacturing and logistics and getting stuff made, when you start looking at what I showed you there with the BMW factory and the work that I didn't show you, but they're getting on with elsewhere, and those kind of dynamics that I just talked about in terms of if you're a business and you're there to make money and, make your product as cost effectively as you can, then you're not going to look this gift horse in the mouth. You're going to have to make a decision. Now, fundamentally, though, go back to your central point about, energy consumption and sustainability of materials and all the rest of it, comes back to what I said earlier, which is the government's not paying any attention. It doesn't know that this is coming. Part of my job is to tell them that and to try and help them see it. But there are very few people properly articulating what's coming around the corner. And just finally, on the Tesla promises that never get delivered, there are 60 plus robot companies in China. They tend to do what they say they're going to do. Just look at how many electric vehicles are coming out of China now and what that's doing to the big car companies around Europe. They're in a mess. So imagine what happens when the Chinese say $20,000 fully functional and artificial intelligent enabled robot can be yours with all its attendant benefits. They are going to proliferate pretty quickly. What if I said to you, for the same price, you could have something in your home that in the morning you could say, I'm off to work now. Can you make sure that the dog's fed and taken for a walk, that the ironing's done, the dishwasher's emptied? Oh, and can you cook bangers and mash for my tea? I'll be home around 6. Oh, the fridge needs a bit of tidying up. Could you sort that as well? See you later. You come home and all that's done. These are the reasons why we buy washing machines, tumble dryers, dishwashers, food mixers, to make all those chores a bit easier. But imagine if you had a machine that could do all of that you and I can do, and you just tell it to go on with it. Oh, by the way, make sure the kids have done the homework. And off you go to work and you come home and it's all done.
Perfect. And
it's acting as a security guard. So, it's going to be, to just final word, I know we've run out of time. I've said it before, but I'll say it again. It's going to be a massive change in society. Probably one of the most profound changes that we've ever seen. And having the opportunity to talk to people like yourselves tonight to give you an idea of what's coming maybe makes you start thinking about how you prepare for it, both for the good and for the bad, because it is coming.
Thank you, Stewart. So, Yeah, that was definitely one of the more thought-provoking presentations I've seen in a while. I know what we're all going to be thinking about and talking about when we head home tonight. So, yeah, just once again, thanks very much, Stewart. Looking forward to seeing you up in Orkney again sometime soon, and we can have a chat about some of the positive things that robotics might bring to the islands.
Yeah.
So, but thank you very much. I really appreciate that. Thanks.
No, you're more than welcome. Nice to meet you all.
Yeah, take care.